Using the great Parham Group resources, we have built a product line that produces the highest quality building at the lowest possible cost. And that's what I'm going to share with you today. A general overview of self-storage metal building construction and the materials and methods that we have found will generate the best return on your construction investment. Most self-storage products are component metal buildings. They can be made out of many other products, but generally speaking, they're component metal. Other products like stucco and brick and block are used to develop branding and give the product an upscale finished look. But the interior construction is mostly metal components, with structural steel added as necessary for additional strength. Component metal buildings are made from pre-manufactured parts. They're like Legos or Tinker Toys, and you can build them in any configuration that you want. You can make it any size, you can make it any shape. They're manufactured with standard shapes and standard strengths, but you can also order things in any composition and any style that you need in order to create the building that you're looking for. The basic metal building components are structural framing, clips, screws, and fasteners, interior partitions, insulation, interior door and hallway systems, exterior partitions, exterior doors, roof, caulk and tape, gutters and trim, and architectural accents. Now, no two companies build a self-storage product exactly the same way. Even if they have the same set of plans, two erection crews will put things together differently. And there are a lot of materials that you can choose from with different inner characteristics in each of these materials. They can look very similar on the outside when you have the finished product, but they have different inner strength and inner characteristics. And the life and cost of the building actually depend on the material inside as well as the exterior coatings. A little bit of knowledge about materials helps you to ask the right questions so that you're ending up with the highest quality product at the lowest possible price. An example of this might be that you may have heard about steel from Mexico and wondered whether or not, if there's a cost saving on that steel, if it's the same type of material that you get here in the United States. And just looking at it, you really can't tell the difference. You can't tell the difference from Mexican steel and United States steel unless you happen to be a very experienced erector. And a very experienced erector can tell the difference just by looking at the product. And they know that the carbon content in steel that's from Mexico is higher. And a higher carbon content means that the metal is more brittle and it's more difficult to work with. And they know that it's going to take more time to install a product that is made in Mexico than it is a product that's made here in the United States. So although you might gain a little bit of economy on price, you're actually losing money by having greater labor costs. Self-storage itself is a pretty simple product. Just looking at this photograph, you can see studs, purlins, panels, piers, a little bit of track, and this is just a few items. But there are really a lot more components that are part of this building. How many different types of components do you think that there would be in an average 50,000 square foot storage building? There are actually about 75 different components. Now that's including the door and hallway system, and that has about 18. Our building begins with the design. The structural engineer's job is to determine what materials should be used and what strength each of those types of materials should be. They also are involved in the method of construction. One of the determinations that they have to make is what types of materials are going to accommodate all of the loads and stresses that the building may be put to. A load is any force that is exerted upon the structure or one of its component members. There's two types of loads. There's natural loads and there's physical loads. An example of a natural load would be snow, the weight of snow as it rests on the building. Wind load is also a natural load, and that's the force of wind blowing at the building from any direction. On the West Coast, they would also have seismic loads, and that would be the force of an earthquake. Physical loads, on the other hand, are the weight of the building material itself, and that's referred to as the dead load. There are also live loads, and they're produced by people, furnishings, materials, tenant goods. Anything that can be moved in and out of the building is called part of the live load. Stresses are the internal forces of a material constructed so as to resist those external forces. Stress is on a molecular level. Tension, as we're showing in this first example, is the stress to pull things apart. Compression, in the middle example, is the stress that tends to push things together. And shear is the stress that tends to keep two adjoining planes of material from sliding against each other under parallel forces. We design on a 5x10 grid system. That integrates all of the metal building components to carry the structural load across the entire slab. Because the load is carried throughout the whole slab, it doesn't need to have expensive perimeter beams, and the slab can be poured monolithically, which saves on both time and materials. Monolithically means that it doesn't have to be poured in individual sections. It can all be poured at one time, as in this photograph. After the slab is poured, if you have masonry columns, the masonry columns are what goes up next, and then the metal building falls after that. If you have masonry and metal going up at the same time, the trades have to compete for material space and workspace. But actually what usually happens is that room is tight on large construction projects, and the trades have to coordinate with each other for the use of space. This brings into play the superintendent's role in effective scheduling and materials management. Having trades work together cooperatively through the course of the project reduces the time that the project takes, and it saves money. If you're using metal piers can go up in conjunction with the rest of the building. If you do decide to use metal piers, we strongly suggest that you use one-piece pre-manufactured piers rather than those that are assembled on site. They are much more sturdy and will last much longer. Manufacturers, even though you would order all of your materials, say from one manufacturer or the majority of them from one manufacturer, those materials might be produced in different parts of the country. And you would have different delivery dates as these materials are trucked in. So offloading piers and other materials, you have to have a forklift, and this is going to cost. So coordination on delivery dates is extremely important to try and minimize your cost of extra equipment that you're going to have to use. And once materials are on site, they have to be effectively organized. Moving materials after they've been offloaded is counterproductive to your efficiency. The best way to organize, if you have the option to do so, is by building and as close as possible to work. It's not always easy in a tight setting, and the erection crew superintendent has to look ahead and plan everything that's going to be going on site. It's also extremely important for the erection crew superintendent to be planning ahead for the materials that are going to be used in the next week to 2 weeks, because if for any reason anything is short or not ordered correctly, nothing can be manufactured of any consequence overnight. So it's going to take some time, and planning is extremely important. How much planning does this entail? How many parts and pieces do you think there are in a typical 50,000 square foot building? About 11,000, because you have all different types of C's and Z's and all different strengths of the different types of material. Structural framing is one of the first things that you're going to be taking into consideration. You do the slab, you do the piers, and then you start with the structural framing. Then the partitions are attached to the framing to give the building added strength. How strong these individual pieces of material need to be is determined by the design, and how strong the physical pieces are is determined by their thickness. Thickness is rated by number. The lower the number, the greater the thickness and the strength. You can see the difference in these examples that we have. We have red iron examples and galvalume examples. The red iron is 12 and 16 gauge, and the galvalume is 22 and 26 gauge. In both cases, the 12 gauge and the 22 gauge are the stronger pieces of material. Weather resistance is determined by the coating on the material. In our previous picture, we had red iron and galvalume, and those are the two most commonly used coatings. Red oxide, which I just referred to as red iron, is a paint coating. It's applied in a blast pickling process. The steel is the same underneath for both products, but red oxide is a paint coating. Galvanizing is a molten dip process that's applied at 850 degrees Fahrenheit. Galvalume is a little bit more expensive, but it's almost always used for partitions. It's also used for studs in coastal areas where they might have higher salt content, or where any weather characteristics are going to make the paint applied coating not strong enough. In addition to those two basics, we also have structural steel. And that's added only in portions of buildings where the loads and stresses exceed the limits of the component metal construction. We build on a 5 by 10 grid system. These vertical framing members pictured here are what are called the studs. The layout for construction begins when the erection crew comes out to the site and they measure the slab. And then they use a plumb line to snap intersecting lines on the slab. Clips are placed on this grid that show where each of the studs is going to be. And the clips have to be placed the direction that the stud is going to face. Sometimes studs face hallways or other construction elements that make it so that you have to turn the stud one direction or another. And you have to start with the clip facing in the appropriate direction. Studs are what we call C-channels. And they're called C-channels because of their shape. We have a photograph here of a 6-inch C and a 4-inch C. The width of the channel and the thickness of the metal determines its strength. And stud size, again, is based on the building design and loads. Purlins are the horizontal framing members. They support the weight of the roof and the upper floors and help to stabilize the building. Purlins attach to the studs as we have depicted here. Partitions are also part of the support of the building, the same as the red iron. This is called diaphragm bracing. Partitions are put up at the same time as the studs and the purlins because they give it additional structural strength. They stabilize the building and make it stronger as construction goes along. And you can see here, it looks like we have different parts and pieces all going up at the same time, and that's the truth. But we do that because it makes the building stronger. Partitions also divide the building into the units. They're strong and they're resistant to wear and tear. These are two pieces of galvalume that I have here. One is a 22 gauge and one is a 26 gauge. Some of the important things to consider in interior partitions are, first of all, the panel overlap. These panels are ribbed panels and they overlap each other. We usually go one section of overlap, and that's so that we can have a double thickness where we put in the screws. It also prevents tenants from getting into one unit from another unit and sliding their hand through. The partition height is really important. You have to make it up to about 4 inches below the purlin, which actually makes it about 8 inches below the roof, not far enough down so that anyone could get through. You have to be sure that the corners fit very tightly, and you have to be sure that it fits very tightly against the floor. You also have to be sure that there are sufficient screws in the partitions to make sure that it is attached properly. There are a wide variety of screws and fasteners used on each job, and they all have to be installed correctly. Something that didn't used to happen that is happening now in more and more cities and counties is that they are requiring torque tests to make sure that the screws are tightened down exactly the amount that they should be. Screws can either be painted in the field or they can be purchased already painted. If you purchase them already painted, they're going to last longer. How these materials are installed is very important. Each clip, screw, and fastener has to be installed in accordance with the plans. Plan details show each type of connection. They specify the type of screw and the fastener that has to be used. There's a correct way to attach every component. As you can see here, plans actually go into great detail about these connections. How many bolts, fasteners, and screws do you think would fit in this ordinary water bottle? Actually, about 220 fit inside that small space. How many do you think that there would be in a simple 50,000 square foot building? Actually, there are about 130,000 bolts, screws, and fasteners in a building of that size. The next part of construction in our project would be the insulation. Insulation is added for temperature control. Generally speaking, it's put in the roofs of all of the buildings, but it's only put in the walls of the climate control buildings. In self-storage, there are a lot of buzzwords about temperature control. You can call it temperature control, humidity control, climate control, etc. Insulation actually just provides a heat resistance factor called R value. The higher the number, the greater the resistance. Manufacturers tell you what the R value is on their product, and the engineer specifies what the R value is supposed to be. We have some examples here of a variety of different types of insulation. They all provide a thermal barrier. Heat resistance is a rapidly growing field, and there are new products coming online all the time. In your decision for what types of insulation you need to use, the most important thing is to use the type of insulation that you need for a specific area of your building. You don't necessarily need to use the same type throughout because different areas are going to need different thermal values. What we are showing here is a radiant barrier for the roof insulation, a scrim ceiling insulation, and a vinyl back wall insulation. The other important thing about insulation is that it has to be installed correctly, without any gaps or any areas where cooled air can exit out of the building. One of the things to always watch for is that areas above entries and places that aren't actually part of the units are effectively insulated. Decking or roofing can go up at the same time that the rest of the building is going up, or it can be added after the interior frame out. Erection crews have to coordinate the roofing with the other trades. Roofing is always an extremely important component of the progress of the building because a lot of trades can't work until the building is already dried in. Dried in meaning that there's no access for water. Insulation is always something that has to be protected by roofing. There are several different types of roofs, and basically the design of the roof is dependent on two things: what the owner of the project wants the building to look like and the requirements dictated by weather. A roof has to have at least 1/4-on-12 pitch in order to adequately shed water. And what 1/4-on-12 pitch means is that for every 1 foot of roof length, the roof has to increase in height by 1/4 of an inch. We've already talked about partitions having to go up toward within 4 inches of the bottom of the purlin and 8 inches from the roof. If you make your roof higher, that means your partitions have to go up higher. And that means that there are going to be more square feet of partition that have to be ordered. So in order to keep your economy as good as you possibly can, you have to keep your roof as low as you possibly can. All of the other components are also dependent upon the final height of the building. There are several different methods of producing a roof that work well. There's standing seam roofs, screw down roofs. Roofs can be rolled on site, which actually means they're actually manufactured on site, or you can buy cut to length pieces and install them. What we use is a standing seam cut to length roof. It's pre-manufactured, so there are fewer potentials for error in the manufacturing process, and there are no penetrations as there are in a screw-down roof because it uses clips instead of screws. So there are fewer possibilities for error in this type of roof, and we have found over the years that it really works the best. In the roofing design, the most important thing is that water always has a clear path to follow. Water control is the primary element of roof design. The square footage of the roof and the height of the building determine the roof's design. In this facility, we have several different types of roof. We have a single slope, a double slope, and there's also a step down behind the office. Any type of roof penetration has to be done with great care. Flashing sealants and tapes have to be used to protect the integrity of any two metal surfaces that are meeting each other. Most people are familiar with caulk-type sealants, but we have a wide variety of sealants and tapes that can be used in metal building construction, and again, they are developing more all the time. To be cost-effective, the building provider has to know what is the best product in any given situation, and the plan details should specify which types of materials have been chosen. Unfortunately, there always are going to be penetrations in roofs. There are penetrations for elevators, HVAC, plumbing. The important thing is that they're designed and installed well. The fewer penetrations there are, the fewer opportunities there are for leaks. And any type of improper installation will create problems. A good erection crew is literally worth its weight in gold. Sometimes people who are new to the industry have a little bit of confusion about what is covered in the interior door and hallway system and what is covered by the metal building provider. Actually, the metal building provider can do both, and they often do. Sometimes they also subcontract to the door and hallway system provider because they are experts in that field and they want to assure an expert installation. The framing, the galvalume partitions, and the roof and trim, those are always provided by the metal building contractor. Everything that you see here in this photograph are all part of the door and hallway system. The soffit, the lighting panels, the hallway system between the doors, and the roll-up doors and walk doors are all part of the door and hallway system. Exterior doors and headers are also part of the door and hallway system. A door should slide up with just a touch of the hand, and it should automatically stop just below the header. Most door manufacturers now have self-adjusting doors so that the tension no longer has to be adjusted by hand. Ground level exterior units like these doors provide both security and color accent branding. In addition to the doors, exterior panels help create the look of the building, and they can be anything from very simple to very elaborate. Panels are manufactured with a wide variety of textures, shapes, and material surfaces. These are a few examples of panels coated like stucco. Panels and trim also come in a wide variety of colors. Color accents make the facility more appealing. Owners with multiple facilities also use color as an important part of their branding. Doors and trim can be very eye-catching to drive-by traffic. Panels can be the exterior of the building, or they can serve as support for another trade like stucco or masonry. Usually a combination of materials is used for the finished look. The most important thing when you're using different materials is that all of the transition points have to be tightly sealed and waterproof. In this application that we're showing, we have a metal panel, we have stucco applied next to the metal and in some cases over the metal, and then a painter comes by afterward and paints the building. There's 3 trades involved there. And the most important thing is to be sure that one of those trades is responsible for making sure that all of the materials are properly sealed. It should be defined in the construction documents up front who's going to be doing what. Trim, gutters, and downspouts. They provide aesthetic appeal, and they also provide water protection. And they can be ordered in the same wide variety of colors as all of the rest of the panels. The square footage of the roof and the intensity of the watershed dictate the size and placement of the gutters and downspouts. They have to be adequate to control whatever the weather conditions are in that particular area. In extremely cold locations, heat strips might be required behind downspouts to keep the water from freezing. In this photograph, we show that the downspouts are cut off and they look kind of odd up that high, but the reason for that is because a snowplow has to be able to go underneath them. Another thing that is also included often in the metal building contract is structural framing for other trades. This project has towers. In this example, the framing sits above the roof, which is already completely dried in. The towers were framed and covered for decorative roofing, and the decorative roofing was applied by another trade. Site work may be the most expensive part of the project, but it's completely location specific. The building on top of whatever site work has to be done is called slab and above. Of that portion of the project, the metal building is usually the most expensive. This graph depicts the relative expense of each part of the metal building package. The structural framing, the red iron, is the biggest part of the cost. The doors and hallways are the next largest cost. And then our interior partitions come after that, and then roofing. Things like architectural accents, they can vary quite a bit depending upon how elaborate you want the building to look. But this is a basic spread of costs. Starting with the most cost-effective design possible and making sure that it has the look and the features and the functions that you want. And then choosing the highest quality materials for the best ease of installation, for their quality, for their durability. Then selecting the very best erection crew that you can use and following through with scheduling and organization and attention to detail. This is going to create for you the quality product that has been built cost effectively and you can be proud of. Thank you for attending our presentation.